Hey guys, sorry I am not here today, but we're still going to go on to the next section because it's so related to what we just did. And I'm just going to have you follow along in the notes as I work through them too. So you need to open your workbook to page 82. I will be checking these on Monday when I come back, so you for sure have to have these done. Since you're going to be following along with me, hopefully I'll be writing slow enough that you can keep up with me and be writing along at the same time. But if at any point you need to, just pause it and pick it up and then finish it later. So we are on page 82 in your notes. We are still talking about isosceles triangles. These are the ones that had two sides that were equal. So above it, you should already have this filled out from yesterday. But we had the two sides that were equal and then the two base angles that are equal because of those sides. Today we're going to just do the converse of it. Converse is the fancy math word for the opposite. And what it says in your notes is that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So in triangle ABC, excuse me, there should have been a picture drawn for you and I forgot to include it, so go ahead and draw a picture. And we're going to put A as the vertex angle, meaning it's at the top, and those two legs are congruent. And then we're going to put B and C as your base angles. So in isosceles triangle ABC, AC is 12. And since this is 12, what is the length of AB? This would be 12 as well. And what it's saying is we would also have these angles congruent as well. So if this was like a 60-degree angle, I know it didn't ask this, but this would be a 60-degree angle as well. So as soon as you have these angles the same, we have these sides the same. If you have these sides the same, we have these angles the same. You can't have one without the other. So then if we look at example 8, these are just true or false questions. And what you see is like triangle inside a triangle. And what I want to point out about this little triangle, ADE, sorry about all the focusing issues, I hope that's not too distracting. What you see about triangle ADE is there are two sides that are equal, meaning it's isosceles. And if AD is equal to DE, then we have two angles that are equal, and it would be the angles across, the base angles. So even though it's not marked, angle E should be marked congruent to angle A. And I also want to point out in the big triangle, so if you can ignore this line temporarily, I have two base angles equal. And if you have base angles, you have sides that are equal. So the side across from A is BC, and the side across from C is the whole thing of AB. So the first question, is it true that AB is congruent to CB? That's what I was just saying. This side is congruent to this side. That would be true because triangle ABC is isosceles. I also want to know, is it true that angle A is congruent to angle DEA? Well, we already said that one, since that's that little isosceles triangle. That's true as well. What you're going to see more of is some of the applications, such as the property of isosceles triangles. This one says that if a line bisects the vertex angle, that's a whole lot of vocab right there. So if it bisects, if it chops in half the vertex angle. So you see this line, and it's coming up toward the vertex angle C. If I need to mark that it's bisected, I need to mark that ACD is congruent to angle BCD. So that's what I'm writing here. Angle ACD is congruent to angle BCD. So it's been bisected. Those things are equal. If that's true, then it's also the perpendicular bisector of the base. Again, lots of words. The word perpendicular, remember, means that it hits it at a right angle. So this line CD hits line AB at a right angle. Perpendicular. It's also the bisector of the base, which means we're going to take the line segment of the base and chop it in half. So the line segment of the base was AB. I'm going to chop it in half. So this half is the same as this half. So when it says what is AD congruent to, AD is congruent to segment DB. Again, if you're needing to pause it at any point, pause it. Example 9 is using this information. So they marked some of the stuff in the picture, but not all of it. So for example, they're giving to us that AT is congruent to TH. I need to mark that. They're giving to us that angle ATM is congruent to HTM. I need to mark that as well. ATM is this acute angle up top. And angle HTM is the angle marked with the X. Now since the X is here, we could also put it over here if we want to. But the other thing I want to point out is these marks tell me that AHT is an isosceles triangle. And if you have chopped this angle in half. What we just said on that previous example is that you've made a bisecting right here. Perpendicular bisecting. So perpendicular, we got the right angles. Bisecting, AM is equal to MH. So that is just from the given information. Now we can answer the question. First it says to find x. X is an angle. Specifically, it's an angle in this triangle. It's not the only way to do this, but this way I'm going to walk you through it. So if I focus just on this triangle, it has a right angle, it has a 54, and it has an x. Therefore, I can write an equation with the 90, the 54, and the x. Angles in a triangle sum to 180 degrees, so that's my equation. We can start solving this by combining like terms. 90 plus 54 is 144. So I combine the angles I know. I'm going to subtract them from 180, since triangles have to sum to 180. That gets me 36 degrees. So we found x. The last part of this is to find the length of AH, which is this whole base, the whole length of that side. It's not an angle, it's the side. We already were told that part of it was 5, and we figured out since it was bisected, this would also be 5 because we marked them congruent. So if this is 5 and this is 5, then the whole thing for AH would have a length of 10. So now let's look at number 10. Let me see if I can make it so you can see number 10. We have an isosceles triangle. It's not drawn for you, but we're supposed to know about it. And A is the vertex angle. B and C are the base angles. There's no picture. That is the first thing I'm going to do is to make this helpful is draw a picture of this. So I'm going to draw an isosceles triangle. Two sides congruent. A is the vertex angle, meaning A is the angle where those two congruent sides meet. B and C are the base angles. It doesn't matter which spot you put those in. So the first question, which sides are congruent? Based on the fact that A is the vertex angle, this side we marked congruent to this side. Therefore, I'd say AB, segment AB, is congruent to segment AC. Then it tells me that angle A is 100 degrees. 100 degrees is an obtuse angle. And you know what, I'm actually going to skip the second part first. Let's answer this third question first. Since it's an obtuse 100-degree angle, we are supposed to find B and C. I'm going to put an X because I need to find it. But rather than calling this Y, it's an isosceles triangle. Whatever this angle is, this angle is. I'm going to call them both X. So to find that measure, I can say that when I sum the three angles in the triangle, I get 180 degrees. Two of those angles just happen to be X's. So when I combine like terms, I'd say 2X plus 100 equals 180. Subtract 100 using our subtraction property of equality. Divide by 2 using the division property of equality. We get x equals 40. So we have these two acute angles and one obtuse angle. Just like what we were saying yesterday about how when you have a congruent side, the angles across them are congruent. It works in the reverse way. If I have a obtuse angle, the side across from it isn't so much called obtuse, but it's big. When you're across from a big angle, you are a big side. So for the second part, what do I know about segment CB? I would know that this has got to be the longest side. Even though I made up this picture and I don't know if it's super accurate, if it's across from the biggest angle, it's going to be the biggest side. So I don't really have a ton of space for it, so I'm just going to write it down here and say segment CB is the longest side. And it's because it's across from the biggest angle. Last one we're going to do today. And again, pause it at any point if you need to. I'm trying to move the light so we can see a little better. We have a picture drawn for us, so that's nice. We don't have to do that part ourselves. And let me try to adjust this. I'm sorry. Hopefully I don't make you nauseous. No idea if I made that better or not, but whatever. The perpendicular bisector of segment CB is segment AD. There's no thing drawn in like that. So I need to draw a perpendicular at a right angle bisector, chop in half. I'm going to chop in half CB. So let me find the halfway point. And it's a segment that comes from A down to D. There's no D in the picture, so we're going to add that in. I'm drawing in something that makes a right angle, and when it does it, it chops it into 2 equal halves. Remember, that's what those little marks mean, 2 equal halves. Angle A at the beginning was 40 degrees, but because I have a perpendicular bisector, 2 spaces up, we just said that that meant that I bisected the vertex angle. Bisect means chop it in half. This would be 20 degrees, this would be 20 degrees. The whole thing's still 40, but now I know it's cut in half. Oh, the other thing I know, the whole thing was 11, and again we chopped that in half. Half of 11 is 5.5, so the length from point D to point B is 5.5. The length from point D to point C is 5.5. So when we go to answer the questions, triangle ABC, that was the original triangle here. Since those 2 sides are congruent, when we classify it, it is an isosceles triangle. Triangle ABD, the triangle on the right, is not isosceles, but it does have a right angle in it. And if it's got a right angle in it, we could say this is a right triangle. So I didn't use my answer blank at all, but whatever. Lastly, I want to find the length of, next, the length of segment DB. Well, we already did that. DB is this section. It's the one that is half of the 11. Half of 11 we said was 5.5. I want to find what CA is congruent to. So just name me the segment that would be the same as segment CA. So CA, if you look in the picture, has this mark. It would be congruent to segment AB. The measure of angle BAD is next. BAD would have a vertex of A since it's the second letter. BAD is 20 degrees. And the next ADB has a vertex of D. So ADB is the 90-degree angle since it said that we were perpendicular to it. Angle ADC again has D at the vertex. And D is a right angle, so 90 degrees. And then lastly, we have to say what angle ACB is congruent to. ACB. It's this angle right here. I didn't mark anything with it, but it's part of that isosceles triangle. If I'd ignore this line down the middle, it's part of the isosceles triangle. And we said in isosceles triangles that if you have 2 congruent sides, you have 2 congruent base angles. So I'm really wanting to know what's the pair of the base angle with C, and then be this one over here by B. It's the only angle with B at the vertex. You could put angle B. You could put angle ABC. You could put ABD. You could put DBA. There's lots of names you could put. As long as B is clearly your vertex, it'll be sufficient. So really a lot of practice of the same stuff we've done before. There is still an assignment in addition to completing these notes because they should have taken you at most about 15 minutes to get all the way through this. So yeah, hopefully that goes okay. Good luck. I'll be here Monday.